B.2, silicon transistors. So we need to understand more basics of transistors. First, so let's look at some, important things about transistors. First, importance of transistors. Why transistors are so important? We want to know the role of transistors. Here, we can start with our brains. We know our brains very important. So we can do a lot of advanced things using our brains. But why our brains can work in an extremely advanced way? So think about that. What's the reason of that? Because in our brains, there are many neurons. So what are the neurons? They are basically the tiny switches. Okay, switches. So look at this name, switches. Control, some states. We know switch. We can control on-off state, right? On-off, two different states. If we can represent two different states clearly, we can use that to form a lot of complicated signals. Switches. So that's the role of neurons in our brains. Similarly, let's look at the role of transistors. Role of transistors basically similar to role of neurons. So look at this. This is a computer microprocessor, or we also call CPU, Central Processing Unit. CPU. So that's like a brain, right? CPU just acts like a brain. Okay? So there is some analogy between CPU, brain, neuron, and transistors. So transistors are basically the tiny switches in a CPU. So look at that. So why transistors are so important. All right, so let's look at other basic facts of transistors. First, it was invented in 1947 at the Bell Labs. That early, 1947. Okay, What transistors do, basically two basic things that transistors can do. Okay, amplifier and switch. Okay. Switch is one thing, so we talked about before, but another basic thing, basic job, amplifier. Make the signal or make the current stronger. Amplifier. Okay, First, let's look at the amplifier. So transistors have this property. Okay? So it takes in a tiny electric current. Okay? At one end, your input, a very small, tiny electric current. Then the other end, it produces much bigger, stronger electric current. Okay? This property. Transistor has this property. Amplifier, this property. Okay? Many real-world applications, we need this property. Okay? Amplifier. All right. Then the second one, even more important than the first property. The second property, switch, this property. So a transistor conducts current across the collector emitter path. Yeah. Here some special terminology is used. Yeah. Here we do not really need to know the detail. Some of the details we can skip. Okay. Yeah. We just know some general idea. Okay. Only when a voltage is applied to the base. So voltage applied to the base, so then, okay, so the current can, pass through, some component easily, right? Yeah. And then when no base voltage is present, the switch is off. So there are two different states can be represented in a transistor easily, on-off state. So we can use it as a switch. See? Yeah. So this property is extremely important because we need this property to represent two different states on, off, right? So we use number 0, 1 numbers. In this way, we can do the logic things. Logic reasoning. Okay? So a lot of complicated things can be represented using 0, 1 states, symbols. So you can see, yeah, many advanced, powerful things can be done through these switches. Okay, yeah. All right, next. Now we want to look at this step. Make transistors from silicon. So here, the silicon is very special. So we want to understand this part, silicon. Yeah. First, yeah, so these three scientists, they invented transistors. Yeah. In, Bell's lab, right? Bell Labs in 1947, right? Then they were awarded Nobel Prize in Physics in 1956. Yeah, because this invention is so important. Yeah. So, in our human history, yeah, extremely big. Yeah. So this big invention, yeah. How big? Yeah. So many consider the transistor to be one of the greatest inventions of the 20th century. Yeah. But here, many consider, but I think it should be everyone, right? Yeah, everyone. Yeah. Because here we say one of the greatest invention. We do not say the greatest invention, right? We say one of the greatest. Who can argue it is not, right? Yeah. So, yeah. All right. So next, silicon transistors. At the beginning, people did not use silicon to build transistors. Okay. Yeah. But later, silicons were used to build transistors. So here, this is a silicon, okay, crystal silicon. All right. 27% of the Earth crust. So we can get silicon easily from the Earth. Yeah. Yeah. But it has some really nice properties. Okay, yeah, here, let's look at that. For the first 6 years of their existence of the transistors, yeah, first 6 years, transistors had all been made with germanium. Germanium, yeah, this kind of special substance, germanium. Yeah, but after 6 years, then the scientists found a better substance to make transistors. So that's the silicon. Okay. Why is that? Yeah. Although there are many different properties here, I only want to point one special property difference. Yeah. The operation temperature of germanium from 0 to 70 degrees Celsius. Celsius degree, not Fahrenheit, Celsius degree. Yeah. So pretty small range operation temperature. But for silicon, much larger than that. Okay? Yeah. So for the silicon, devices function from -55, really low, to 125 degrees Celsius. Okay? Yeah. So much bigger range. Yeah. So you can see, yeah, for that particular reason, it is a better option. Yeah. Definitely, there are many other properties. Yeah. But here I just mentioned one, simple property. Yeah. All right. So then, by the end of the 1950s, silicon had become the industry-preferred semiconductor material. Yeah. So for a lot of reasons. Yeah. So then, semiconductor industry. Yeah. Finally, yeah, always use silicon to build transistors. Okay. All right. Yeah. So we want to learn a little more about silicon. Yeah. Basic facts of silicon. First, we want to know who discovered the silicon. Okay? Yeah. A Swedish chemist called John Jacob Berzelius. John Jacob Berzelius. Okay? Yeah. Yeah. In which year? The year discovered 1824. Yeah, approximately 200 years ago. Nearly 200 years ago. Okay? Yeah. The silicon element in chemistry. Yeah. All right. And this special substance, so why is it so special? Yeah. Because it has this nice property. It is a metalloid. What is the metalloid? It has the properties between metals and non-metals. Sometimes it acts like a metal, sometimes like non-metals. Yeah. So based on, some special condition. Yeah. So people can put a control on that condition to make that change. Okay? So that's very important. So that's the reason we can use as switches, right? Two different states. Okay? Yeah. So if we do this kind of thing, then we get this state. If we change, right, the voltage, we get a different state. So this property is critical, yeah, to build a transistor. Yeah. All right. Next, easy to get. Yeah. The cost, not very high. Yeah, easy to get. Yeah. It is the second most abundant element on Earth by mass, making up over 27% of the Earth crust. Mainly the Earth crust part, right? So not other part, but still a lot. Yeah. So we can get easily, yeah. But the hard part is, although you can get a lot of silicon easily, but the hard part is the purity. Purity of the silicon. That's the hardest part. To make it useful to build transistors, how to make silicon as pure as possible. That process that manufacturing process is most important. Yeah. All right. Silicon crystal, then this property is useful. In order to get very pure silicon, so we need to use the properties of the silicon crystal. Crystal. So I think you know the crystal, right? Crystal has its own properties. Yeah. All right. So here, for silicon crystal, there are two types. Yeah. But this type, we need this type. So what's the monocrystalline form? Polycrystalline, monocrystalline. Yeah. These two different types. But to build the transistors, we need this type. Monocrystalline form of silicon. Yeah. And this special type we need to use to build microchips. Yeah. So this is a picture of pure, very pure silicon crystal. Okay. So 99.9999%. That high purity, very high purity. Yeah. So in the next video, I will give you the more information about manufacturing process to make the silicon crystal, extremely pure for transistor microchips. Yeah. All right. All right, so let me stop here for the second video. Now, the third video, we will, move to manufacturing microprocessors. Yeah. So, that process. So eventually, we should get microprocessors, the CPU, or microchips. Yeah. So there are several different names. Yeah. All talk about the same thing. Yeah. All right, so let's stop here for